Good evening. Welcome to the meetup. We're going to go through some the different aspects of blockchain tonight, and I'll just give you a quick kind of overview of some of the things we'll be talking about, starting with blockchain and transactions, some of the installation that you can do to run it from the command line and run it locally, because typically if you're going to work with blockchain or any of these sort of currencies, you need a database on your system, and that's typically 250 to 300 gigabytes, and so that I don't have. So you can do it, a lot of the testing locally. And then the language for Ethereum, which is called Solidity, and it's similar to JavaScript, and then a few other topics, including BitCoin and some of the controversy there. So in essence, blockchain is a distributed system, like a distributed database. And the advantage of doing that is having such a system instead of a typical, normal, regular database is that users can access data in a very secure fashion. And the idea is that the data is stored in these blockchains, which means literally chains of blocks that are kind of like sort of like a linked list, if you will. And so what happens is, I'm jumping way ahead, is that you use a hash function, and the hash function for a particular block is used for the subsequent elements that are blocks that are chained to that. So if you change it in one place, you have to go update it. That's why you can't go in there and kind of tweak it somehow secretly, and then nobody knows about it. Well, it invalidates things. So that's kind of one of the key ideas. The thing about it is that it's not intended to be storing like large images or videos, for example. It's really for small amounts of data that really involves the state of objects, if you will. I included this link from Larry Summers. He was a U.S. Treasury Secretary. I think he's the president of Harvard, or at least after he left the government. A very outspoken individual, and likes to tell it the way it is, the way he sees it. So it's kind of interesting. He's basically kind of a conservative person, so I don't know, I guess it might give it some sort of validity beyond what it already has. So this is some of the history. Starting with this concept of having a cryptographically secure chain, and that was, what is that, 26 years ago. And then, as you can see, the progression. Blockchain didn't really start until 2008, and then things started happening. One of the interesting things, actually from TechCrunch last weekend, meeting people there who are saying that there's a demand, that it's increasing. This is all anecdotal, of course, so you can't really quantify it, but apparently there is definitely interest in blockchain in particular, and also with Ethereum developers. So that might be something if you're looking to explore. And I actually, a couple of weeks ago, Brendan Eich, the guy who invented JavaScript, he tweeted something about, oh, Ethereum developers are in demand. And that wasn't too long ago. So he also has a browser called Brave, and he does some blockchain stuff in there. I've got some links in there later on. And so here are some of the advantages. I kind of already alluded to it. The ability to store things permanently, and if you're going to make changes to the data, it invalidates the hash, and so you have to go through a process to revalidate it again. And the interesting thing is that this system is decentralized. So there's no central control, there's no central bank, if you will, that has access and extra admin privileges, so to speak. And I think there are advantages to that. People have wanted that kind of thing. It's kind of a throwback to an earlier era when there was no internet, no technology of sorts. It was basically a barter system. So it's the barter system meets the 21st century, maybe, sort of, in some aspects. So the underlying technology, blockchain, is essentially a platform. And on top of that, there are applications and currencies. BitCoin is essentially one of the first big ones. The contracts is a very big thing for Ethereum. This is a generic type of contract, any kind of contract, whatever. When in the, what do you call it, the UCC, I think it's that, the Commerce Code, from what I remember back in MBA school, if two people make an agreement and it's over $500, a deal has been struck. And then if somebody violates it, you can potentially sue the other person. But if it's less than $100, that key point cutoff is $500. So here, there's no restriction, no limit, whatever the contract is that two people arrange. And of course, it's secure because of the cryptography that's involved. So things like your information, personal medical history. Imagine going to the doctor whenever you go, they can get that information in a secure fashion. However, keep in mind when you're working with these things, two things. Contracts. Oracle Contracts has been around for some time, and it's part of their ERP suite. So it's integrated into a financial application. This is not at that level. It's just a pure, simple, vanilla, generic kind of a contract with security involved, of course. So it would take potentially a lot of work to make that, or for someone to come along and have it sort of pluggable into an ERP system. And what would the benefits be of that? What would it be for Oracle? I'm sure they're looking at that to decide, is it worth the effort to convert? Or is it one of those things where if it's not broken, don't fix it? And that's kind of the reason why languages like COBOL for financial institutions, they're there. It works. There's no reason to convert to C because they're not getting anything that they don't really need. So that's kind of something to keep in mind. And also other things, for example, there's a HIPAA compliance in the medical field. I believe it's medical. There's SOX, Sarbanes-Oxley, all these different kind of things. If you're going to start making it legal and viable where it can stand the scrutiny of various laws and regulations, you need compliance. So despite the benefits of having this system, that might be the easiest part, and then all the other sorts of things which existing systems have. So there are these trade-offs, and those are things to consider before you decide to jump in and create a transaction system for ERP. Here's just a quick diagram. It's actually in two parts. When there's a transaction involved, as a simple example, it doesn't have to necessarily be a contract. It can be just a money transfer. Normal. And so this is the sequence here. You can see how the progression here. After the third step, where it's broadcast to every party in the network, those in the network approve the transaction is valid, and then it can be added, et cetera, and then it's done. The part that I'm not quite clear on yet is how do you determine how many people need to be on the network to approve the transaction? Everybody? Half the people? One? That's the part that's a little not quite clear to me.
Everyone has to approve this?
I don't know. That's...
It's called, everything is immutable. That's what they try. So if you do a Merkle tree search,
yes,
in Wikipedia, you can do it.
I've got an example about that.
So it's a binary tree. So each node has the data of the block, and then as you traverse up, it's a hash function, and the hash, if there's a hash key, this is for the next
sure.
level. The next level will have an input from the previous hash. So
right, but that's not the question. The question is how many people need to be on the network to approve?
So it comes from the gaming theory. Okay? Multiple people, random number generators, multiple people will be there on the network.
That's not the question. The question is, this transaction goes out for approval.
Okay.
How many people must be on the network to approve it, regardless of the details?
Yeah,
Three. Thank you.
Comes back, they're done.
There you go. That's the answer. 3 people.
There's no number. Anybody will do unlimited, but they wait for 3.
The minimum is 3.
Yeah.
If 3 people, here's the algorithm. If 3 people, at least 3 people approve, done.
Then they wait for the rest of things to come.
That makes sense.
There's no number, yeah.
Okay. So just to kind of go on with that a little bit more, this is again a little bit more detail about how it goes on, where you have each computer is a node in the system and it has access to all the data. So everybody's database, what's on their system, is updated. So of course, given the transactions that take place, the amount of data that's going to be added has to be relatively small. Because 300 gigabytes is not a big deal for laptops, but if it starts getting into the terabyte range, that could potentially be problematic. At what point in time can it and will it? I don't know. Maybe a few years from now, hard to say. But that, as you can see, obviously you can't store a video or images, and as I mentioned earlier about large amounts of data, is prohibitive. And a little bit more about this, as you can imagine, there are aspects of it that work the same as you would in any system, any transactional system, whether it's ERP or command line run. It has to be atomic. If you take money out of one account and you move it to the other account for consistency, ACID. So the same is true for blockchain transactions as well. That part's no different. And so there's a security system, the SHA-256. Is a hashing algorithm. I think, I remember the SHA-128, I don't remember exactly, was cracked a few years ago. And so there's 256. There's also 512, I believe, and maybe 1K. And so that potentially would have to change at some point in the not too distant future. And as you brought up, here's an example of something mentioning the Merkle tree. It's a hash of hashes. And so it's a system by which you can confirm data and so forth. So hashing, in case that's new to you, is actually quite simple, the concept. You have some sort of a message, a string, what have you. It passes through a function, and that function then determines this hashing value. Now, in some cases, what people have done is use extremely large prime numbers. And why is that? Because you want to minimize the collisions. And collisions occur when two different things have the same hash value. Now, that's not necessarily problematic in general when you're working, for example, let's say you have a Java hash table. You've got some processing some records, you've got IDs that are in there. No problem. If they collide, there's the kind of the what do they call it? The extra, not the bit bucket. I always get that confused. There's that essentially, it's slots in the hash table, and then if need be, there's a linked list that goes on past that in that particular slot. So it's a combination of this slots plus linked list. And the thing is that that's not what you want to have happen when you're working with blockchain. And just to point out something I didn't include in the slides, there's something called, I don't know if I should mention it, well, it's open source. It's called IOTA, IOTA, and it's on GitHub. And they wrote their own hash function, allegedly. And their problem was that there were collisions. And there was a security team, I think from MIT, that goes around and checks various things. And basically what happened was they went into GitHub, looked at the code, and they saw the flaw. No one bothered to check. So that raises another point. When you're going to be working with Ethereum or whatever else, when you're writing this code, how do you ensure that you don't have bugs in your code? Or how do you detect bugs? How do you fix them? What are the side effects? How much leeway do you have, in other words? That part I'm not clear on quite yet. Maybe it's not something to be concerned about, but something to think about at least. And so this is the format for a blockchain block. And as you can see, at the rightmost end, there's the previous block hash. So that's how you get that sort of link. It's pointing toward the current one. And so what happens is if you change the data, the hash is invalidated. So what you can do is coming up in a couple of slides. this is slightly out of order. The way to secure blockchain data is also to use obfuscation and encryption, as I mentioned before. And I think, sorry, I'm out of sequence here. We'll come back to that in a bit. Some of the blockchain implementations, essentially, you can think of them as applications on top of a blockchain platform. BitCoin, of course, Ethereum, and also, interestingly, IBM Bluemix, which I've seen a number of different blog posts and on their website. You can actually do quite a bit. So it seems like IBM is starting to take it fairly seriously, and there are other companies as well, as you'll see in the list of this consortium that exists. And just to drop down to the command line, if you want to install a blockchain, I mean the executables, you have to install npm if you don't already have it. And if you're on a Mac, you need to use sudo, and then notice the rest of this, the blockchain-CLI, that's kind of the standard naming convention. If you have an executable ABC, you're going to install ABC-CLI, command line interface. That kind of become kind of a de facto standard. And G-G. Now, this part is new. I had never seen this before because I never needed it. And that you use if you get permission denied at the end when there's a post-install step. And I ran it as root, as sudo rather, so why wouldn't have permission, thinks something's going on, whatever the case may be, that's a nice handy thing to have because you can use that with other things as well, not just with the blockchain. And now, if you want to launch it, just type blockchain, and that's what you'll get. And notice the list of commands on the left. I'm going to show you a couple of them. One is just called blockchain, and the other one is mine. So the blockchain command option shows you the state of the blockchain, and then mine enables you to create a new one. So this is what you get when you type blockchain. The previous hash, there isn't one. It's empty. And timestamp, date, blah, blah. And then it gives you the hash here. And then the nonce. And that, we'll see in a minute what that is. Here's what happens. I typed mine and then hello BC for blockchain. Notice here, this is the previous hash, pointing to the earlier one. And then here we go. So we have created it. It's very quick. And the data in there is just simply that string. So here's a little bit more information about the fields that I showed you in a particular blockchain element. And they call it Genesis. That's essentially block 0. The values for the nonce value, I believe that's the pronunciation. It's pronounced nonce. And that's the thing that needs to be updated. And in addition to updating the hash. So this is what happens. Just as a simple example, you have 3 elements here, A, B, and C, and you change A. Well, then the data in A. Then you change that invalidates the hash, so you have to update that hash. Then, of course, B's hash is going to be invalidated. That has to be updated, and then finally with C. So that's kind of essentially just a more of an explanation of what I was saying before about the way these blockchains are connected. So, Ethereum, I've mentioned already a few times. It's, as we talked about earlier, one of the more prominent layers on top of blockchain, and the language here called Solidity, which enables you to write code in the Solidity language, write Ethereum applications. And you can create these things called dApps, which are distributed applications. They also, the good thing about this, one of the advantages of Ethereum is that the transaction time. Now, from what I understand, you pay for contracts being committed and approved. The faster that process takes place, the more you're going to be charged. That's my understanding. And so, there's no free lunch, so to speak. And there's some various advantages, as I already mentioned, and one is that it's gaining enterprise-level adoption. In fact, that's the only one I hear about in the enterprise space. If they're talking about anything related to blockchain, right now, so far, they're always talking about Ethereum. You can read some of the disadvantages here. Just in the interest of time, I didn't go and list them, but you can certainly get the details there. And so there's an aspect to this that you need to keep in mind is the volatility factor. And that's, of course, that depends on how risk averse you are. And there's an interesting discussion related to sort of this, which we'll talk about in a little bit later, regarding the strategy to adopt. I'm not here to encourage or discourage anybody from doing anything related to blockchain, Ethereum, and Bitcoin. I'm aware of various things, but I'm not going to be promoting it. I certainly, no one's paying me to say anything about them, so there's also various denominations, and the interesting ones, that SZABO it's a Hungarian name, actually. I'm not sure how that came about. But the other ones, you notice the kilo, mega, giga, tera, those are the first letter in front of ether. So you get, I guess it's kether, mether, gether, tether, not tether. And so there's various things that have happened again with Ethereum. There's been a fork that happened not too long ago, and it's a split. I guess under other circumstances, you maybe call it a schism. Not so bad in this case here. And here's the enterprise alliance that I alluded to before. And as you can see, there's Microsoft. I don't have IBM on there. Actually, I don't even know. I'm not sure if IBM is part of that consortium. Maybe now. But there's a fair number of companies. It's a recent consortium. We'll see where that goes. In case if you wanted to get into the enterprise space, I would imagine it would probably be a good idea to start with these, and also IBM. See what they have in common in terms of the skills that you may want to acquire that give you some kind of marketability, better than doing it sort of randomly. So we also mentioned dApps being distributed applications. What happens is very, very high level. You have in the blockchain, you've got some shared data and data logic. On the client, you've got credentials, private data, and an interface, which you'll see in a moment. And so Solidity, the language for Ethereum, similar to JavaScript, developed in 2013. The interesting thing is, for developers, is that it actually supports single and multiple inheritance. Not sure yet when you would need to do that, but it's kind of a nice, I guess it's a nice to have feature. So if you're going to install Solidity on Mac, which everybody here has, you need to install Xcode, and that's typically a 4 gigabyte compressed file. That when you forget what the format is now, they changed it. So uncompressed, it's like 8 or 9 gigabytes. And this would be the command that you run the first time. Subsequent times, whenever you do an upgrade, there is these command line tools that you have to downstall. Has anyone installed Xcode, by the way? Okay, so what happens is, if you forget to do that, no worries. Just launch Xcode, then it'll show a pop-up and go, these tools are needed. It'll just do the download for you, which is nice. And there's also a binary package, and there's a compiler for Solidity, which is called SOLC. As you can see, the installation is there, the command for doing so. Now, real quick, we'll go into some data types and also little code samples. Boolean string and int, as well as uint, and that's kind of a interesting kind of a throwback to C programming and C++. I haven't seen that in years, because that's when I was doing that sort of thing. And so the other thing is, of course, it has, as an object-oriented language, public and private we're familiar, but instead of protected, it's got internal and external as some of the access modifiers. Here's a simple, trivial example that does really nothing except return a string. As you can see, instead of saying class hello world, it's contract. String type function. The public goes afterward. You see how it has a returns keyword. So the syntax is a little bit different, but essentially very much similar. It looks a little bit like Scala almost, kind of. And there you set the string with the hard-coded value, return the value. And as I pointed out below, multiple return values are supported. It's kind of nice to have. Here's a slightly better example, not much though. It looks like a value object of the VO. So here you have a contract and this unsigned int for my data. You have a setter and a getter. It's starting to look like something that could be used in some other contract. And you can invoke contracts from other contracts. This one does a little bit more. It has a pragma, so you can specify the version number. So what is that like? Not sure really which other programming languages have that. Yeah, you're right. You can use, there's use and restrict. So you can, there is some of that, correct. The other thing is, what happens is another, something like NPM or package.json, the versions are specified there outside of the code. So it depends on the style you prefer. It could be advantageous to have it in a single configuration file, but this is how they do it. And if you want to do the setup on Windows, there's some other stuff there that you can do. Chocolatey, I'm not familiar with. And I don't know which particular Windows build tools are required for this, but you can investigate. So when you create a contract and you saw an example of the code, you compile it to bytecode. It's called truffle. Upload, wait for the contract to be mined, and here's the truffle framework. It supports all of these things. So it's kind of a nice utility function, and here's how you install it, as you can see below. And to start off, you run truffle init in a directory. As you can see, we did a long listing down below. You can see there's a standard truffle.js file, 3 different directories. If we, in this case, I actually created it under this directory here in red, and then I ran truffle init. Here's all the files that are there. You can see the contracts, migrations, and test, and the truffle.js file. So when you're doing your testing, as I mentioned before, you want to do it locally, you need another executable, Ethereum.js-test RPC. So it creates some other things, convenience things like test accounts, and you can run from the command line. So it's actually quite useful. Code samples, as I mentioned, they're about IBM. Here are some of the ones that you can get from IBM. And there are some for blockchain and JavaScript, and I put them in those samples on this particular slide. And then something about mining cryptocurrency. You can look at that later on as well. So, Bitcoin. There was a discussion today between 2 people in the financial, and it was very lively. There was very much the pro and very much the con, and they were relatively civilized about it. The interesting thing is, again, from my standpoint, the takeaway that I got, which is at the end of the presentation, the live session, the person who was against essentially said the following: let's suppose that you're right, that it's going to be really successful. So you're going to be a millionaire, billionaire, whatever. Well, in that case, take some of the Bitcoin currency, convert it into something tangible and type of asset, so you can hedge your bet. It's essentially diversification. So that way you'll still be a millionaire / billionaire, and you'll have that. And if it crashes, you'll have something. I like that because I'm very risk averse. And so whether you agree with whether or not Bitcoin is going to be successful or not, I think that's a wise strategy. But again, I'm not saying that anyone has to do anything other than what they want. Let your own judgment be your guide. So here are a few things about Bitcoin. And of course, there's still apparently no one really knows who the person or persons are who created Bitcoin. I've heard that this Satoshi Nakamoto is a billionaire, so he may have been, have a significant influence in there, perhaps. And so, again, this is another thing that we're talking about as being an application on top of blockchain. And that's kind of pretty much it in terms of, you can read the bullet points there. So, This is the person I was talking about a minute ago, Robert Schiller. He's a Nobel Prize winner, I believe. He wrote Irrational Exuberance. That book, he's written about when there are these different crazes, apparently, and he's been right at least some of the time. And he was the person advocating that sort of diversification, if you will. So take that for whatever it's worth. This is another interesting thing, Bitcoin Cash versus Core. Bitcoin Core is the typical, what used to be called Bitcoin. And I'm not really sure about really the details, but I direct your attention to the link at the bottom of that slide. And so I guess somebody's panicking about that. So I would definitely recommend reading that blog post. So cryptocurrency, just a link for where you can read about the vulnerabilities. And notice in there that's talking about IOTA. And one of the things that is, you have to, I mean, kind of stating the obvious, you have to know what you're doing. You have to understand how hash functions work, and at least whether or not you ought to be devising your own, and whether there's another existing hash function. There must be. People are using this successfully, so whatever they're using, and that's probably a good place to start. And so if you read the that post, I believe that's the one that I kind of skimmed through. Lots of detailed information, and sort of stunning in a way that, you know, how could people not check? Everybody dropped the ball. Everybody's assuming the other guy checked and verified. Well, you know, maybe they did, maybe they didn't. Equifax, here's another one of recent demise. There's also some ransom that was involved, some threat that to give them some amount of money, otherwise all this information would be destroyed and all the repercussions thereof. Another one here, we have China has banned cryptocurrency, but then we say, oh, it might be temporary, that may change, so hard to say what all is going to happen. Yet another one at the bottom, you can actually get an MBA in cryptocurrency if you live in Russia. It's kind of interesting. So I'm kind of wondering, I said to people, I'm wondering if my regular MBA will just become sort of null and void and useless. Maybe so. So this is the a diagrammatic explanation here of hashing collisions. And you could see what the different ways to represent it. This is one way to do it. Here's another way to represent it. And then you see how the overflow. So I'm still trying to remember what that term is when you have the linked list. There's a name for that.
So I think these and buckets.
Yeah.
So when there is a collision, then you add it as a linked list.
Correct.
And that happens value.
Sure.
The hash will be input, right?
Right, but I'm.
Last element, that's what is.
Yeah, it's the term for that part there where you see the extension there.
Offset.
Is it the offset? Yeah. Minor detail. You can find out online. And then here's another example here where you have collisions. So whichever graphics you happen to like. And interestingly enough, at least for me, one thing that I definitely am interested in because of the deep learning aspect is blockchain and LSTMs. Those are called, or they're part of RNNs, which are recurrent neural networks, and LSTMs are sort of the darling of the hour, or for now, long short-term memory. And there's a link at the bottom where you can look at that in more detail. Here's a little bit more about that with machine learning, and a few links where you can investigate. There's a PDF, and let's see, I think that was close to the equities market with blockchain. The interesting link there is the list of dead coins, and there's always, that's an interesting aspect of this whole thing. How many coins are there? How are they there? What are the ones to pursue, to go after? See, that adds a layer of complexity because we don't think about that. We have money. It's all done transparently. And even when we go to a foreign country, we pay with our card and it's all transparently handled. Now, you don't have that luxury. And again, since I'm risk averse, I don't want to become involved to the point where I need to know all that kind of information. It's just too much information. So a couple more things I mentioned earlier about blockchain and the Bravo browser, and Ethereum and Azure. And the last link is kind of interesting. I haven't read that actually, but it's a nice, interesting title. A few more blockchain links, just kind of miscellaneous things that I found looking around. The first one is how does blockchain really work? That's probably one of the better ones here, or potentially more useful in terms of details. And that's just about it. Here's some recent books of mine. This is what I do. And this is a free online Kotlin course from hypersoftware.com, hyper without the E.